right, how do I start this? So I want to talk about education, I want to talk about open source, I want to talk about Thea Flowers, because the interview today is with Thea Flowers. And all this stuff is very exciting for me because I'm a teacher, and I am not your traditional teacher who comes and basically gives all the answers with a lecture and hopefully you remember everything. I'm the kind of teacher that just asks you, here's a question, and you're like, but how do I figure this out? And I say, good, this is where you start learning, because you just need to figure it out on your own. And I rely on people like Thea Flowers who basically share knowledge online, because the course is about you figuring things out, you finding your way through and learning how to learn. Because when you learn how to learn, it's like a superpower of an artist or a designer, because you can just find your way. When you get stuck, you know where to look. And that's basically why we have a community. That's why open source is so important for creative people, for people who want to learn on their own. Now, this conversation goes to a lot of different topics because I'm really interested in how she actually learns herself, but it also just touches on her modules, which you probably know of. And if you're interested in open source, or if you're designing your own synthesizers and always kind of like on the fence, should I open source it or not, you'll probably have an answer here, because this is what I wanted to figure out with this conversation. Anyway, without further ado, this is Thea Flowers from Winterbloom. I am Roy from the Synthux.academy. And by the way, we're actually organizing an international hackathon in January, so you might want to check out the website. I'll try to remember to link it down below. Anyway, drifting again. Enjoy this conversation. Thea Flowers, Winterbloom.
A lot of things in my life tend to be kind of chaos, and my creative process is also a little bit chaotic. But I think once I've got an idea, right? Once like the creativity is kind of settled, in terms of like the big picture, right? Like, and that tends to come from things like, what do I need? What do I want? What sounds interesting, right? But once that sort of idea has coalesced into something that's a little bit more solid, my sort of engineering training kicks in, right? And that's where like my engineer mind starts working. And what I tend to do is I always start with pen and paper. I draw out like, sort of a mind map of like, here's the thing in the middle, and then like things that I think of that come off of that, just, branch off from there. And kind of let my mind wander and just kind of make associations and stuff like that. And then from there, like I'll go, okay, what do I want? What do I want it to do? What do I want the inputs to be? What do I want the outputs to be? Like, what should this do? What should it feel like to use this? What sort of problem am I solving, or what sort of thing am I bringing to the table? Right. Like, I think what's really important for me when designing hardware and synthesizers is like a vision of like, this is what I want it to be at the end, because I don't always know exactly what it's going to look like, but having some kind of vision helps a lot. For example, with Castor and Pollux, which is a dual Juno-inspired oscillator, I didn't really know what it was going to look like in the end. I just knew that I wanted to make something inspired by the Juno, but slightly different. And there was a bit of a journey to get there, but I'm glad that I didn't like set myself up so rigidly in the beginning that I limited my creative options down the road. And once I sort of like have some sketches, it depends on the kind of module where I go from there. If it's a hardware only sort of thing, or hardware mostly sort of thing, I'll go to the breadboard, or I'll design a small printed circuit board with a bunch of different options for doing things, and just kind of explore circuit options, right? I also tend to use the Circuit.js, the Falstad simulator a lot, which is really useful. Maybe not so much for audio circuits, but definitely for like just kind of setting out and just exploring how to like modify a control voltage and how to like sort of just do the basic, ins and outs and routing and stuff. That way I can focus more on, the harder parts, like, how does this deal with audio and on all that stuff. And then, sort of once I've had a chance to sort of test some ideas out and see what works, see what doesn't work, or see what needs to be modified, then I start to kind of think about, how does this fit together into one package? How does this become a module? How does this become a synthesizer? And to kind of give an example of Speak to Me, which is my newest module that is releasing on October 1st. It is a tiny little speaker, but it's also a high quality headphone amplifier. And it actually came out of this need for us to have an easy way to check audio outputs on our modules when we're testing them. Because we had to like, set up a whole like, output module and, headphones and all this stuff. And that was it's just too much. It sucks to kind of like keep repeatedly doing that. So having a little speaker that we could just plug the output into and hear it immediately was really, really useful. But I also thought to myself, like, okay, that's useful to us, but how do I make this useful to other people? What parts of this are actually useful and what's missing? And to me, what sort of came to mind was, okay, I love having the ability to just monitor any point in my modular synthesizer. Like the speaker is really useful for that. So like, if I'm building a complex patch and I just want to listen to like just one part of it real quick, that's perfect for that. But also when I'm ready to record or perform or, do something, I want a really solid, high quality headphone amplifier or line driver, right? And so, the thought was, could I put those together? Could I have a delightfully lo-fi speaker and an incredibly hi-fi useful headphone amplifier? And yeah, I could. So, a lot of that was kind of building two separate products at once, like building the speaker amplifier and stuff, and then building the headphone amplifier and line driver, and then smashing them together. And in the end, I'm really happy with what came out of that, right? Like once I know what the functional aspects of things are, that's when I can start thinking about the aesthetics and the design and that sort of stuff. And of course, like none of this is strictly linear. Like things like it's sort of a like repetitive circle, right? Like it's iterative. Every part of this process, like kind of informs every other part. And I think it's important for me to take my time and iterate and give each project the amount of time that it needs to really like coalesce.
Right. So how long is this whole process?
It depends. It's funny that you asked that, because with Speak to Me, my thought was when I started it, like, oh, this project doesn't involve any microcontrollers. It's, relatively simple. It has a very small BOM count. It's going to be an easy module to develop. It took me 8 revisions, which is like more than any other module that we've made. And that was a surprise to me. It was kind of frustrating, but now that it's done, I'm glad that it, I gave it space to do that. But this process takes anywhere from a month to 6 or 7 months. And it just depends. With Castor and Pollux is kind of an interesting case, because I spent kind of a year doing research in the background, and I don't really count that towards time developing the module. But once I decided to actually start developing the module, it went by pretty quick. I think it only took like 3 months. But the research leading up to that took a long time. So I don't know. It just depends. And then like we have modules like Big Honking Button, which I developed in 2 weeks. I mean, I definitely did some refinements for it later on in later revisions, but the core idea was done in 2 weeks. And yeah, That was it.
Why does it take 8 revisions to finalize something like this? I mean, as you said, it is just a speaker, it is just a preamp.
That's a great question. I ask myself that constantly. uh, the perfectionist side of me is like, why did it take you 8 revisions to do this? But
well, the
on a more
perfectionist should
serious
actually
note,
be happy with it. It's like, the project deserved it. Otherwise, it's not enough.
well, like there's also like the perfectionist side of it. It's like you should have gotten it right the first time.
Oh my God. You should not listen to this,
but
folks. Should not listen to this, folks.
I usually do a good job of not listening to it, but I mean, part of it was that I'd gotten 2 revisions in or something, and then both the speaker amplifier that I was going to use and the headphone amplifier that I was going to use, just the stock just dried up. It completely disappeared from supply chains, and I essentially had to start over with a new headphone amplifier and a new speaker amplifier. And of course, they were not one-to-one drop-in replacements. They were close, but they required, a little bit more doing. So that was kind of a big reset button, 2 revisions in, and that set us back a little bit. The other thing was just making a bunch of small mistakes, which in retrospect, like some of them were surprising just because of the different behavior of the headphone amplifier, the new headphone amplifier versus the old one. Some of them were interesting. Like I had an issue with the second speaker amplifier that I picked because it was just driving too much power into the speaker and would cause the speaker to overheat. And I actually burned myself on the speaker while testing it. That was a very surprising result for me.
That is not ideal.
Yeah, because like I've done guitar amp mods and stuff like that, and I've never experienced a situation where a speaker got too hot to touch. But yeah, a little bitty speaker. And
it wasn't a short.
Happy.
This seems like something that would like.
No,
that's weird.
Super mismatched. And I didn't catch it until I had already built it. Yeah, it was a very strange experience, but I figured it out, and I actually ended up going with a different speaker amplifier that's all around just a better choice for this project. So I'm much happier about that. Yeah, I mean it's a lot of stuff like that. It's a lot of you think you're done, and then you just find one thing that doesn't work quite right. I mean, the last revision I did literally added 2 identical resistors in the signal path, and they're not strictly needed. They're just there to help the module not kind of go into a bad set of behavior if someone does something in a very particular way. Essentially, they're there to make sure the module doesn't overheat. If you plug in a mono cable into the stereo output jack, because by doing that, you actually short the right output to ground. And some headphone amplifiers can just deal with that, and they don't care. This particular one, because it's designed to deal with some like higher impedance headphones, it will actually end up driving that output pretty high and causing itself to overheat. So there are some basically some thermal protection resistors in there to keep things from getting out of control. And yeah, it's just something I didn't catch until like into validation testing, where it's just like, oh no, this one tiny edge case, and want to make sure that it works. So
yeah. Well, I don't think it's such an edge case if you're talking about modular, because people could very easily just connect the output to another output, another input of something. So it would be a mono cable.
Yeah, I mean, in this case, it's the 1/4 inch like line out. But it's not uncommon for people to take a mono instrument cable and plug it into that, and then plug it into their audio interface. So yeah, I wanted to make sure that worked. Yeah, for sure.
I wonder,
and didn't cause any issues.
I wonder if my Motu is actually that smart if I would connect something to the headphones out that is mono and not stereo. So you were talking about the circuits. These, I'm assuming, are analog circuits.
It depends. It depends on the module.
No,
To
I
me,
mean
everything's
this
analog. Yeah,
this
everything's
particular
analog
one.
Mhm.
Yeah. Is it discrete?
No, absolutely not.
Okay.
It's way too small to be discrete. It has 3 ICs total. It has a TL74 as a preamp attenuator, and then it has one headphone amplifier, one speaker amplifier, and both of those are monolithic integrated.
Right.
Yeah. So yeah, not discrete. It doesn't need to be. I mean, the thing is that for modular stuff and just, for a lot of audio stuff in general, like the idea of building a discrete amplifier these days is kind of like niche, right? Like even companies that sell like super high end preamps and stuff like that, like it's a lot of the same stuff underneath. Like you get like a high quality DAC for your computer, right? Like a audio DAC. It's almost certainly going to have an AKM IC in it that's doing all the heavy lifting. And whether or not it sounds good is going to depend on how well they chose the passive components around it and how much you paid for it, because the placebo effect is real. So
I was surprised when I learned about all this, because I used to cherish my RME interface because of the conversion. And then I learned that it's basically all the same ICs. I was like, what? They're not making their own ICs for this? Like, why do they, why is this more expensive then? And I still don't really have my answer. It might be that there is something to it. So I don't know.
Yeah. I mean, it makes some sense in like guitar amplifiers where like,
Oh yeah.
building something discrete there makes a lot of sense. Or like if you're building a power amplifier, like it makes a lot of sense to go discrete just so you can have better control over thermals and stuff like that. But for line level stuff, the stuff that we're dealing with, like, yeah. Like, I mean, I did a lot of tests with Speak to Me, and going into several audio interfaces, both from like a cheap phone interface like to my Focusrite interface. It's been it's been no different from my oscilloscope, right? Like it's been great. So I can't really tell any difference, and I don't think anybody else will either.
No, I know. I mean, niche, when we say niche about something, I think that it's a very subjective thing, because some people would say that Eurorack is niche. And I would be what are you talking about? This is like a world. Like, yeah. I know people who would even say that SMD is too small, because like if you think about the amount of silicon in it, you cannot compare it to through-hole components, because it will sound different because of the amount of material.
Yeah, and the amount of metal around to gather up EMI, yeah. It's definitely going to sound a little different.
Yes, it's definitely going to sound a little different, but yeah, it really depends on like what you want to like. I think you just need to pick your battles.
Yeah, that's my point of view on it, because like I'm a guitar player as well, so like I have a tube amplifier, right?
Oh yeah,
I have
me too.
an ancient piece of technology that is just totally superseded by like every component of it is superseded by something else now. I mean, you could get essentially the whole thing in one IC at this point. But there is something to be said about that old school point-to-point wiring and tubes and all that stuff. It is unique. And then on the other hand, on the other side of things, I'm like, no, I'm not going to pick that battle with a headphone amplifier. Like we can just use normal stuff. A company that I really respect in this aspect is Schit Audio, SCHIIT. They are an American company that make like hi-fi pro audio stuff, and they're just so upfront about their products, and it's great. They're like, yeah, this like they have a a USB DAC and they're like, yeah, this uses the same AKM as everybody else. They're like, here's what we've done to, make it worth you buying it from us. And they're like, we use high quality film capacitors, high quality resistors. It's got an aluminum enclosure. You've got support in America. You've got, a 2-year warranty. And it's like, that's honesty is refreshing in the pro audio industry.
Oh yeah.
And it's that way for all their stuff, like from their speaker amplifiers to their phono preamps to everything. And I highly respect that. It's one of the things that I wanted to kind of keep with Winterbloom. Is just, we're honest. There's no reason for us to lie about, our stuff and say that like, oh, it's got some magic fairy voodoo dust in here. It makes it sound better than everything else. And that's why you should pay $500 more for it.
Yeah, I think this is really the old approach, and it's seen in other forms and factors inside of what we buy. From documentation to the feedback you can actually get from the company when you reach out to them, customer support, and some people just understand this, and some people evolve and grow into something that's a bit more modern, like what you're just describing. Being more honest is not really a problem, and others look at it like, hey, this is how things are done. If you don't understand this, then you can build your own market, but this is our market here, and this is how it's done. Yeah. But you mentioned that you're doing analog electronics, but I know that you're actually coming from like software. You're not an engineer. Like, well, you're an engineer, but not an engineer of like electronics. What's the deal here? How do you learn all this stuff? How do you get into this world? It's not easy.
It is not. So you're right. I'm not an electrical engineer. I have been a professional software engineer for the last 12 years or so. It was an adjustment. And I'm still learning. I mean, like this is definitely a constant learning process. And so is software engineering to another degree. Like, but for me, it really was like kind of this search for something like physical, tactile that I could touch, right? Like I spent a lot of time in my career working on web stuff and working on graphics and things like that. And it's just kind of like, okay, it exists, but it just exists on a computer somewhere and there's nothing tangible, right? And it's like, okay, so I wanted to try out hardware stuff just to see if I could make tangible things. I actually started with mechanical keyboards. And the reason why I was drawn to mechanical keyboards was because, I'd been dealing with RSI for a bit and I wanted to try out some different options.
RSI?
Yeah. So like repetitive stress injury. So like things like carpal tunnel and stuff like that. Yeah. So like, I wanted to try out some different options and stuff like that for keyboards. And I found this whole community of people who just build their own, and also like this whole like mechanical keyboard community that's like obsessed with aesthetics. And it's so similar to Eurorack that it's so funny to me. Like, but discovering this and building my own keyboard and all this stuff, like I'd known how to solder, I'd known how to sort of put things together, but I didn't really understand like sort of what was really going on the covers. So as I learned like how these keyboards actually worked, like it's a bunch of switches and a matrix, not super complicated hardware to understand, but understanding how they worked and like how to customize their firmware and stuff. I was like, oh, this is really interesting. I would love to like dig a little bit more into this. And part of my software background is pretty interesting because I have done some development for hardware in terms of like video game hardware. So I have experience writing both Game Boy games and Sega Genesis games. And so like being somewhat close to the metal wasn't unfamiliar to me, but being close to the metal in modern days was pretty unfamiliar to me. So yeah, like a lot of that was really interesting to learn. And, I sort of started with keyboards, and then, I got an Arduino and I played around with it, and I, went through a bunch of tutorials on that. And I was like, okay, this is neat, but what is it actually doing under the covers? Because like I said, I came from that mindset of dealing with assembly on Z80 and 68K. And I was like, so what is this really doing under the covers? Because Arduino is so high level that it kind of hides a lot from you, which is great, but also I'm curious and I wanted to know what was going on underneath. So, I ended up doing a lot of just exploration and messing around. It's kind of how my brain works. And eventually I was like, I think I'll build some synthesizers with this stuff. And then from there, it's, you just keep learning. And I think, there are kind of like two secret weapons I have in terms of learning this entirely new thing. The first of which is just open source. I mean, without open source stuff, I wouldn't have had anything to look at to learn from, right? I could have read books and stuff like that. But the cool thing about open source is that, especially with hardware, is that you get to see actual designs in production and what sort of decisions people made and what compromises had to be made and things like that. Because when you read books, especially about electronics, a lot of it is theoretical, and they don't always discuss the real world things that you need to worry about when you're actually building these circuits and trying to implement a product with them. So you go and learn about, certain circuits or op-amp circuits and stuff like that in a book. And then you go and look at some open source project and you're like, this is different. Why is this so different? And doing that research and understanding why that is the case really helps build that depth of knowledge. The other secret weapon is just a community. I think the most important thing that you can do when learning anything new is find people that already know it, or find other people who are actively learning it, and attach yourself to that. It's get in with that community, hang out, lurk if you must, but hang out, ask questions, just see what other people are doing. And through osmosis or through active participation, you'll learn a lot. And for me, I became a part of the Adafruit community pretty early on in my electronics journey, and that community has just been fantastic for me in terms of learning and sharing, and just making it a lot easier for me to wrap my head around all of this stuff.
When do you start sharing your projects?
It depends.
So in what phase do you feel like, okay, I should get some feedback on this? Because you come from software, so in software we know how quick this can be to get feedback.
Yeah. God, that's been such a big adjustment to hardware. It's and I make a hardware revision. It's not hit compile and see what happens. It's send it off and wait a week for it to come back. And it costs $30 to $50. It's that's a whole different ball field. But I think in terms of sharing, I tend to still follow sort of the open source software philosophy of share early, share often. With open source, it's release early, release often. For me, I have a Discord for Winterbloom, and there's people in there that I respect and trust, and they're people who are both my customers and my friends, and I'm usually not very shy about sharing stuff with them and getting feedback from them, and they give really good and thoughtful feedback, right? Having that sort of dedicated user group is super important, and it's something that I learned from my previous work in developer relations and software engineering, is that when you're launching a beta or an alpha of a developer product, you want to build a small but engaged user group to give feedback in those early stages. And I sort of accidentally built the same thing with Winterbloom, and it's great. I talked about Speak to Me pretty early on in the design process with the folks on my Discord, and asked them things like, what sort of things would you use this for? Would you actually want this? How big would you want it to be? Like, where would you use this? And I got some really good feedback. And like one of the things I think that was super useful is people mentioned portable setups, which is not something that I've ever done with Modular. But a lot of people like to, take their setup and run it off of, a battery bank or something and go out into the wilderness and play Modular. That's cool. But it made me think about, how good this module could be at power consumption, right? Like, how could we make sure that this is efficient in a way that doesn't drain your battery immediately if you're out using a power bank, right? So that informed the design of like how I designed the power section of this thing, and how I picked the amplifiers and how much power they draw. In the end, ending up with like a relatively efficient module for what it does, which is great. Like, and there's also the aspect of if you're using headphones, the speaker side of it turns off entirely, so you're not paying the cost of any power for that while you're using the headphones. So stuff like that is really useful. Like sharing early, sharing often is great. I also tend to post on Twitter a lot. I'm working on a module called Binary Star, and I can't produce it because of the chip shortage. Basically, the earliest that I can even think about starting to produce it will be next summer. And the hardware is basically done, but the software is not. And I want it to be a customizable module. I want people to be able to sort of make it do their own thing. And so, I'd share on Twitter a lot about like sort of this flow-based kind of pure data looking interface for making it do different things. And Twitter is a mixed bag. Sometimes you get good feedback. Sometimes you get not good feedback.
To say the least.
Yeah, to say the least. But, I think it's really interesting sharing stuff like that to a slightly more broad audience, just because even if people don't like give you good suggestions, people ask questions. And when people ask questions, that gets your own brain thinking about things. And to be honest, a lot of times with things like Twitter, I don't want people to tell me how to do something. I hate when people tell me how to do something. I guess that's like part of my rebellious streak from being a teenager that never went away. But when people ask questions, it's like, oh, that's a good question. Like, let's explore that, like, I think that is super valuable. So yeah, I mean, I tend not to be shy about sharing stuff. Part of that is just my open source background of like, I'm going to release this all anyway, so I might as well just go ahead and show it whenever I want to. And yeah, I mean, like, I understand for a lot of people how that can be scary, because if you don't completely feel like you know what you're doing, you're scared of being judged, right? Like, you're scared of people like being like, oh, you did that totally wrong. And I share some of that fear. But on the other hand, I'm also kind of shameless when it comes to design. So, if I put something out there and someone's like, oh, you did this totally wrong, I'm like, cool, let me figure out how to do it the right way. After I get over the initial emotional reaction to someone telling me I'm wrong. But yeah, that's kind of how I go for it in terms of sharing stuff.
I had a post on Reddit where I created this thing as an educational kit for students. This was the first time that I actually designed my own PCB from scratch, and it has a bunch of modules, but it's also very Fiat Lombardo in the approach of like playing around with the way that you're creating things to make this look really beautiful. But it's for educational purposes, so I tried to do something that looks really cool on one hand, on the other hand needs to be really informative, and this was really challenging because it doesn't. Absolutely. I mean, it's much easier to just put everything in boxes. Then I put it on Reddit and I got dozens of hate messages, like how horrible of a teacher I am. And it was, I mean, I have an elephant skin. I don't. Is this a term? Elephant skin. This is definitely a term in Hebrew. Yeah. Okay.
Yep. I've heard of that.
Yeah. So I really don't mind. I just like, okay, whatever. Like all the hate messages, I just whatever. And then I get some questions, just like you said, and I think these are really valuable. What happened that I thought was the most striking is that even until now, I get students of mine. So I shared this on our Discord community, not the Synth one, but another one that I have with students, and I showed them this is how much feedback I get on stuff, and I think you should learn from this, because this is a really, like, your teacher here is getting also really bad feedback, and that's good.
I'm so glad you did that. That's awesome.
And then students still come back to me and say, you know, Roy, because you shared this thing, like, I completely changed the way that I do things now. And I feel like I really sped up the process for them, because for me, it took years to get to the point that I developed this kind of like approach of like, this is not me. It's just this thing that I've built, you know, take it easy. If you can get so emotional about it, that's your problem. I'm not getting so emotional about it. This is just a thing. It was a fun learning experience, and now I'm learning from what you say, or not if you're an asshole, but that's okay.
Yeah, no, I get that. Like, for me, I think it came from, again, my previous job in developer relations, where like I'm trying to get people to use a product that I didn't necessarily completely design, right? Like I may have like informed some of the design of it, but you know, I'm trying to bring it from the inside to the outside, and you got to have some level of like detachment for that, right? Because
absolutely.
Like, sometimes you're taking a product to beta and you're like, this product is not good. Like it's going to get some bad beta feedback, and you know it, but you also know that like you have to get that feedback for the people that are working with you to understand what to change and what needs to change. So yeah, like having that level of detachment is really useful. The only time I get really frustrated is just being a woman on the internet. It's frustrating, period. Being a engineer who's a woman on the internet is, oh God, sometimes so obnoxious. I can't tell you the number of times like I've had people just try to explain things to me that I'm an expert in.
Oh my God.
I once had someone email me and like explain SVGs to me, and I've been working with SVGs for over a decade. Like I'm also a graphic designer, and it's just I just read the email and I took a picture of it and I sent it to my friend, and I was just like, I was like, can you imagine explaining SVG to an expert in SVG?
Yeah, but you know, yeah, I don't know. Maybe they didn't know. You know, maybe they were. I mean, considering that someone actually sent you an email, that's maybe nice. You know, like they just wanted to help, or maybe they didn't.
Well, yeah. I mean, there are the emails that are like, okay, this person's just, you know, misguided. And then there's these emails where, in this particular case, is one of them where like this person just felt the need to be right.
Oh my God.
Or like feel like they were right, and it's just like, oh no, come on. Like, don't you have anything better to do with your life than bother women on the internet?
Yeah.
And the answer for a lot of people is apparently no, but but yeah, I mean, it's a common thing that happens. I mean, I'm in a couple of communities, Discords and stuff like that, where like we have a specific channel to deal with like venting about this particular kind of thing. And the stuff that happens is just incredible.
Yeah.
So yeah, that's fun. But you know, once you sort through that stuff, you can get some good feedback. And with Reddit especially, it is so dicey. Like there are some subreddits where people are super helpful and aren't always jerks. Like I think like the Synth DIY Reddit is relatively good in this aspect. There are other subreddits where, holy crap, everybody is terrible. Um, I think the electronics subreddit is one of these. The moderator in particular is really terrible.
No.
Yeah, he has like some weird personal vendetta against me. I don't know what's going on with that. But yeah, I mean, like, Reddit is such a mixed bag, and you kind of have to be careful. So I feel bad for students who are just like, oh, I'm going to share my thing to Reddit, like, and they pick some giant subreddit that's filled with jerks, and it's just like, oh no, you poor thing.
I actually send them to do that. It's part of the challenges. Like, yeah, you should go to Reddit. It's like no one dies from it. You just go to Reddit, ask some questions, learn about assholes. These are assholes. These are nice people. Now you know. You don't know before you do that. You just need to do it once. And I think it's good that you do it in an environment where someone is kind of like guiding you and taking you through the way. And like, okay, try to post this here, see what happens. You see, this is an asshole. Now you know.
Well, I'm glad that you're there for them for their trial by fire.
Yes, I think it's better than you just discovering it on your own and be like, what is wrong with me? Nothing is wrong with you. It's wrong with them. It's all good. Yeah, but let's definitely talk about failure. So if if you think about the first mistakes that you actually made, and how you probably now overcame them, and you have improved the way that you're designing circuits from the inside. I think that what you just described about the clever management of power in Speak to Me is really interesting, because it's it's very mindful. I think it's very, very mindful of a particular user and a use case. So I would be curious to learn what kind of mistakes you've made at the beginning that were like, oh god damn it, like this needs to be like that, and I wish I would know that.
Yeah, I mean, I think like there are mistakes like, oh, I forgot to add a current limiting resistor to this thing, so now it's going to overheat. Like, those are mistakes and oversights, right? Like things that I missed. But then there's things that are like, I didn't know better, right? And I think for those things, I try not to sort of see them as mistakes or failures, but see them as just part of the journey. Because I think for me, a big part of just all of this is just learning, right? Like up until 2 years ago, I had never tried to manufacture electronics, right? So like there is a big gap between messing around with an Arduino and shipping a product, right? And there's not a whole lot of resources for crossing that gap. So for me, it's like, I can look back on my first designs on Soul and to some extent Big Honking Button, and there's definitely things that I would do differently. But on the other hand, I know that like I did pretty good with what I knew at the time, right? And like Soul is a particularly interesting case because it was the first module I designed. And looking at it now, there's a lot of things that I would do differently. For one thing, the mechanical design was just not there. I think, I paid so much attention to getting the hardware right, the circuit working the best that it could, that I sort of left the physical mechanical design as an afterthought. And because of that, Soul is actually kind of hard to build. There's a reason we don't sell Soul kits, and that's because it's a huge pain in the butt to put together. Like when we first started building it, I think the failure rate for the jack boards, the board that holds all of the jacks and the LED and the USB port, was pretty high, and it was very discouraging for me. I found some ways around that, but in the end, I'm like, this just needs to be designed differently, right? Like the circuit's okay, but just the whole way that this thing gets put together just needs to be designed differently. Another thing that I can point out on Soul is that I was still getting used to surface mount stuff. So I ended up using like larger resistors and capacitors like 0805s and 1210s. And while those are a lot easier to solder and deal with, they are also more expensive. So when you're dealing with manufacturing, it made things more expensive than they needed to be overall. And it's not a huge increase in expense if you're just building one thing, right? But when it adds up to when you're producing 100 or 200 of something, that increase in cost for every passive component can add up to a lot. So yeah, I mean, like, I kind of look back at these mistakes or oversights or just things that I missed as just ways to learn. And what sort of came out of Soul and the learnings there were really just all of the ideas that I had for Binary Star, which is kind of a follow-up to Soul. And with Binary Star, it improves on Soul in almost every dimension, right? Like, Soul is 8 HP. It has a jack board and a circuit board behind that. So it's a relatively deep module, and also there's a lot of things to put together, and I have to order more circuit boards and all this stuff. Binary Star is 6 HP, and it is just one circuit board behind it. And it's a lot more dense and a lot harder to route and debug, but in the end, it's going to be a lot cheaper to produce because it's smaller. It's and it only has one circuit board to deal with. And I also learned a lot about like sort of making sure that like there are visual indicators for things, right? Like Soul has one LED, and it's used for mostly for just like acknowledging whenever a MIDI message comes in. Binary Star still has that, but it also has LEDs on every input and output that show the polarity of the input and output, which is so useful if you're, putting together a patch, or if you're, changing the behavior of Binary Star. It's really, really useful. So yeah, I mean, it's stuff like that where it's just like, I just didn't know any better at the time, right? And so I think it's important for me to like make it where my modules are not some static fixed thing that just never gets updated, that they are kind of continually improved. And I think maybe that's something that like I still hold over from the software world, where it's like you don't just release one version of something and tell people to make of it what they can. You make changes, you release things, you take feedback, and you incorporate that. I think Castor and Pollux is a pretty interesting case there too, because while I haven't made any hardware revisions to it, I've been able to do a lot with the firmware. Like for instance, after launch, people asked about sort of making it play an octave higher all the time. And I just added a firmware feature for that. And, it took a couple hours and it was released. And now Castor and Pollux had a new feature. Some other people asked about different LFO shapes, because Castor and Pollux has an internal LFO, and by default, it's just a triangle wave. So I was like, oh, that sounds cool. So I added an advanced LFO feature that lets you choose between different wave shapes, but also combine two different LFOs together if you want to, for more like sort of chaotic, interesting LFO. And that's just a software feature. And yeah, like, the stuff that I've been able to add to Castor and Pollux after the fact using software has been really interesting and cool. I'm happy for that. So I've definitely seen, instruments and modules and stuff like that, where it's like they run firmware, but the company's never ever released an update for it. If they even planned for an ability to do that, right? And part of that on Castor and Pollux was also just making the firmware update process really easy. You don't have to, have some weird connector, and you don't have to like scream audio into one of its inputs or something like that. you just plug it in via USB and it shows up as a USB drive, and you just drop the new firmware into there and it's done.
The Scream audio thing was a thing that I discovered with Modular. I was like, seriously, is this how I update this? And I thought it was actually quite funny. But yeah, it's not the.
I think it's funny and super interesting, and it's I understand why it's a thing. Like for a lot of these older modules, they didn't have the benefit of having microcontrollers that had native USB support. So that's a really useful way to get firmware updates without requiring a special adapter when you don't have the ability to do USB. But I have the benefit of using, more modern microcontrollers that have native USB and can just do USB based firmware updates, which I think is really cool.
How do you deal with updating and adding features to something that already has an interface? Like, isn't it confusing for someone to work with it when they don't really have the signifiers, the correct signifiers, basically, to the LFO, for instance?
Yeah, definitely. The idea with Castor and Pollux is that, for the most part, the interface on the hardware is pretty simplified, right? Like, the idea is that the interface on the hardware exposes the things that you would want to change during a performance. That's the idea. The rest of the stuff is hidden, or not really hidden, but is accessible through the settings editor. So things like offsetting the pitch by 1 octave and making the whole thing play an octave higher or octave lower, that's in the settings editor. That's not necessarily something that you would want to change during a live performance. But what we like, on the other hand, like things like the LFO frequency, like you can hold down the hard sync button and turn the LFO knob, and that'll change the LFO frequency. Whereas if you don't hold that down, it just changes the LFO intensity. So yeah, like you might actually want to change the LFO frequency during a performance. And other things like the LFO shape, that's not generally something that a lot of people would want to change in the middle of a performance. It might be very surprising to change during the middle of a performance. So that's in the settings editor too. I mean, I've definitely wondered about, making it where people could assign these things to physical controls if they wanted to. Because, there might be a case where someone wants to switch between LFO shapes in a live performance. But, my goal is really to make the most common cases easy and to make the harder stuff possible, right? Whereas I think with a lot of instruments, it's like, okay, you get what you get. And, the stuff that you think of like, oh, I wish I could do this, is just impossible. Whereas, at least to some extent with Castor and Pollux, like there's a lot that we can make possible. If maybe not quite as convenient and easy, but possible.
Yeah. So let's talk about open source. I'm really curious about this because I know that you're a huge open source person, and your whole vision, I think, as a creator, is more on the educational side than even on the product side. And I know that a lot of people, especially from maybe the old world, look at open source as like why would anyone do that? Because like you have a business. Why would you, like, you for years are learning all these skills on your own, and then you make all these mistakes and you spend all this money to build something, and then you just give it for free and be like, oh yeah, you can just get this. You can pay me if you want, but like it's here for free. You can just take it. How does this work?
Yeah, it's really interesting to me, like that open source software.
Explain it to a boomer.
It's really interesting to me that open source software caught on long before open source hardware, and to a greater extent still is, because like the thing about hardware is that even if you give away the source to it, it's not trivial for someone to make it, right? Whereas like with software, it's like, oh yeah, you can give it away for free and people can just download it, right? But with hardware, it's like, yeah, you can give away the schematics and all that stuff, but someone still has to have the know-how to put it together. And it is largely the case that most people don't have those skills or don't have the time to do that. So for hardware, it's kind of like a no-brainer to me, where it's like, yeah, like people are still going to pay me to make these because there's a ton of people out there who don't want to make them themselves. And for the people who do want to make them themselves, I can also sell kits. And, for a lot of people, that'll just fill that niche for them because it offers them the experience of putting something together, but it also offers the convenience of having all the parts in one place. They don't have to go and find all the parts and order PCBs and stuff like that, right? And then, there are a handful of people who will just take your source files and send them off to a board manufacturer and, come back and make it themselves. And that's okay. I mean, I've had people, email me for help with those things. And for the most part, I do what I can. But, like I've never been worried about individual users, not like missing sales on individual people because of open source. That has never, ever been an issue for me. Where I think a lot of people have some hesitance is like, okay, what if someone clones your module? What if someone, what if Behringer, God forbid, decides that you're their new target and, they're going to clone your stuff? Well, my point of view on that is just that open source isn't going to save you. Like, if a company with the resources of Behringer or even half the resources of Behringer wants to clone your product, they're going to do it. I mean, they did it to Arturia, right? Their stuff is closed source. Did not slow down Behringer at all.
Mutable instruments and many others. Yeah.
Yeah, I mean, Mutable is open source, and a lot of people use that to kind of justify Behringer's behavior. But, like, sure, technically, legally, sure, ethically, no. But yeah, it's like open source is going to save you. And actually, I think open source is maybe even counterproductive in the case of like dealing with another company cloning your product, because what happens is that if a company with more resources clones your product, they are able to produce and create more of them at a lower cost than you will ever be able to. And open source or not is not going to change that. But what open source does give is, while you may not be able to regain your power there, your users, the people who like your stuff, who use your stuff, they have the power that Behringer has as well at this point, right? Like, they don't have to invest in reverse engineering resources like Behringer did. They don't have to, do all of this work to be able to produce the thing. So, in a huge way, it kind of democratizes the ability to make something. And for me, and for my goals, and this isn't true for every company, and I'm definitely not saying that every company should be open source, but for me and my goals, like, I would rather everyone be able to make my thing than for only me and some big company be able to make it. Like, I would want that power to be in the hands of everyone rather than just in the hands of me. And I feel like if I ever made a closed source product and some company cloned it, I would open source it out of spite. Like, I'd be like, okay, you spent all this money, cloning this. I'm just going to open source it now so that, anybody can make it. Now that you've spent the money to rip it off. Yeah, I don't know. I mean, like, that's kind of my outlook on open source hardware. It's just like, I think the biggest fear that people have is just, oh, what if somebody else makes this instead? It's like, okay, if they wanted to do that, they were going to do it anyway. And, you build a fan base not by being the only person that has a product. You build a fan base by being the best person that has a product, right? I mean,
yeah.
I mean, think about it. Like, how many, like, your rec has a bunch of unique modules, but we also have a ton of non-unique modules, right? Like, how many VCAs are there? How many quad VCAs are there? How many, VCFs are there? I mean, there's countless. And, it's the same thing with guitar pedals, right? Like how many distortion pedals do we have? And you build a brand, you build a company, you build sales not through just having the only one of things of something. You build a brand through having something unique in the experience or in the design or just in how you carry your business. And I think that that's far more important than trying to protect some intellectual property.
That's a good approach in general, I think.
Yeah, I mean, like I said, it's not for every company, and I'm definitely not going to sit here and advocate that everyone should just open source all their stuff tomorrow.
It's interesting that you say that. Like, yeah, go ahead. Sorry.
Just like like I know that in a lot of cases, this business is very hard to get buy-in, and any kind of risk of losing sales, especially during this time, is very scary and not a risk that a lot of companies can take. But I would love to see more companies do one-off open source projects. Even if everything else they have is closed source, I would love to see like an open source synthesizer from like Korg or something. Like that would make my day. I would smile forever on that one. Or even just smaller modular companies, right? Like I would love to see IntelliGel or Make Noise open source something. I think that would be really neat. But yeah, I just like I don't advocate for everyone to switch fully to open source all the time like we do. I don't think that's necessarily a business model that works for everyone.
No, but actually Erica Synth has like a lot of modules. They just stopped with producing DIY and just said, okay, this is all open. You can make a business off of it. Like the license is completely open for you to do whatever you want with it.
I love that. I was so happy when I heard that they did that. I was just like, that is if you're not going to do open source at all, making your discontinued products open source is, God, it's just the best thing. Like I love that. I mean, I get it. Like, keep the farm secret or whatever, but whatever you're done with, just let it out into the world. I wish video game preservation was easier in this way. They're like, when a company is like, okay, we're no longer selling any of this game at all, or we're going to shut down the servers for this online game. I wish they would just release the source code, even under a non-commercial license, just so it would be easier for us to preserve. And I don't know. I think, to some extent, I feel that way about synths and electronics. Is like, yeah, if you're going to stop making something, cool. But, tell us all how to make it so we can preserve it, so we can repair it, so we can, make our own if we need to. I think that's really, really great that they did that.
So I would like to ask just one last question because I actually have a lot more, but I think that we need to wrap up.
That's okay.
So if you're talking to students or young designers or artists who want to go into this space, what would you wish for them to focus on? Like, what would you want to see in 10 years time when you're like 22 years into the industry, or maybe 12 years into the industry and 22 years into like being an engineer? Like, what would you want to see the next generation make?
I think more than anything, I would love to see more of a commons. In open source software, we kind of have this idea of a software commons, right? It's the whole body of open source software that everybody can learn from and draw from and build from, right? Like, Linux is a huge thing, like in terms of open source commons, right? Like we have this incredibly powerful operating system that anybody can use and is free and is the bedrock of so many things that we build. I would love to see something like that for the music industry, for music technology in particular, where, we're not always just rebuilding every instrument, every module, every plugin, everything from scratch, where we have built some shared knowledge, some shared tooling and a shared sort of way of working together that encourages more creativity. Because when we free ourselves from having to think about redoing all those things that so many people have done before us, we are able to think more creatively about future things, right? Like, I mean, you can look at the guitar industry as sort of an example of this, right? Like with electric guitars, sort of early on in the industry, a lot of people were like trying to figure out how to clone the Stratocaster. But once they figured that out, they stopped doing that as much, and they started innovating, and they started creating different kinds of guitars. And I think in a lot of cases, and Behringer is obviously a great example of this. It's like we're building a lot of the same things, but we're wasting a lot of effort doing it, right? Like we're not sharing how we did it and why we did it and all that stuff. But I think by building some sort of commons, some sort of open source hardware or some sort of community or something where people can stop reinventing the same op-amp circuits over and over again, and instead think about creative ways to apply them. I think that's probably what I would love to see.